Hi everyone, welcome to this episode of Coding Interview Questions. Today, we're going to talk about a classic dynamic programming problem, climbing stairs. Here's the problem. Imagine you're standing at the bottom of a staircase with n steps. Each time, you can either climb one step or two steps. So the question is, how many different ways are there to reach the top? Sounds like a real-life scenario, right? You can take it slow, going up one step at a time, or speed up a bit by skipping a step here and there. Eventually, you'll get to the top. What we want to do now is turn this everyday situation into a math problem and figure out exactly how many ways there are to get to the top. Let's start from the simplest cases and build our way up. To make things easier, we can draw a small table and keep track of the number of ways to climb the first few steps. If there's just one step, there's only one way to reach the top. Take a single step. If there are two steps, you can either take one step at a time or jump two steps at once. So that's two ways. Now, what about three steps? You could take one step, then one step, then one step. Or one step followed by two steps. Or two steps followed by one step. That gives us a total of 3 different ways to climb. Now, if you look at the table, 3 equals 1 plus 2. Interesting. It seems like the number of ways to reach step 3 is the sum of the ways to reach step 1 and step 2. But let's not jump to conclusions just yet. Let's look at step 4. If we try to list out all the possibilities, it gets a bit tedious and easy to miss something. So let's change our perspective. To reach step 4, your last move must have come from either step 3, by taking one step, or from step 2, by taking 2 steps. That's it. Those are the only 2 options, since you're only allowed to climb 1 or 2 steps at a time. So, the number of ways to reach step 4 is just the number of ways to reach step 2, plus the number of ways to reach step 3. And we've already calculated both earlier. 2 plus 3 gives us 5 ways. Now looking at the table, you can clearly see the pattern. This is actually a Fibonacci sequence. Each step's count equals the sum of the previous 2. In math terms, we can write this as f of n equals f of n minus 1 plus f of n minus 2. With this formula, we can calculate the result for each step starting from the bottom. This method is known as bottom-up dynamic programming, also called the tabulation method. By the way, if you're not too familiar with the Fibonacci sequence, or if dynamic programming is still a bit fuzzy for you, I highly recommend checking out the videos I've linked below. They'll help you build a solid foundation. Alright, now let's take a look at the code. First, we handle the base cases. If n is 1 or 2, we just return the result right away. Otherwise, we use 2 variables, say a and b, to represent the number of ways to reach step n minus 2 and step n minus 1. Then, starting from step 3, we move upward 1 step at a time, all the way to step n. In the end, we return b as the final result, the number of ways to reach the top. This whole process is linear. The time complexity is O(n), and since we're only using 2 variables, the space complexity is O(1). It's super efficient. Besides going bottom up, there's another common way to think about this problem, top down. Instead of building from the ground up, we analyze the problem from the top and work our way backwards. Think about it this way. To reach the nth step, you must have come from either step n minus 1 by taking 1 step, or from step n minus 2 by taking 2 steps. Those are the only 2 options, since you're only allowed to take 1 or 2 steps at a time. So the total number of ways to reach step n is ways to reach n minus 1 plus ways to reach n minus 2. That gives us the formula f of n equals f of n minus 1 plus f of n minus 2. Now here's something important. You'll notice this problem has overlapping subproblems. To solve f of n, we need to solve f of n minus 1 and f of n minus 2. But the thing is, f of n minus 1 and f of n minus 2 are really just smaller versions of the same problem. So we solve the smaller problems first, and then combine their results to get the answer to the bigger problem. In this case, combine just means adding 2 numbers. That's also a classic feature of dynamic programming, something we call optimal substructure. It means the best solution to the whole problem can be built by combining the best solutions to its smaller parts. This kind of structure is perfect for recursion, so we can write a simple recursive function to solve it. Now, this recursive version looks clean and intuitive, but there's a big catch. It's really inefficient. Why is that? Let's look at an example. Suppose we want to compute climb stairs of 7. If we draw out part of the recursion tree, we'll see something interesting. Climb stairs of 5 gets called twice. Climb stairs of 4 gets called 3 times, and climb stairs of 3 shows up even more. In other words, we're solving the same subproblems again and again. As n gets bigger, this repeated work gets worse and worse. The time complexity becomes exponential, which is extremely slow. To fix this, we can use a technique called memoization, also known as top-down dynamic programming. We still use recursion, but we store the results of each subproblem after we compute them. Next time we need the same result, we just return it from memory instead of recalculating it. This gives us the same performance as the bottom-up approach. The time complexity becomes O of n, and we still keep the recursive way of thinking. So if you're someone who likes breaking problems down step by step, this method might feel more natural to you. So, to wrap it up, climbing stairs is a classic dynamic programming problem, and it's a great starting point for learning the technique. We explored 3 different approaches. The first is bottom-up dynamic programming with iteration. It's fast, clean, and very efficient. The second is plain recursion. It's simple to write and easy to follow, but it's also slow. The third is top-down dynamic programming with memoization. It keeps the clarity of recursion while adding the speed of dynamic programming. In a real interview, unless you're specifically asked to use recursion, I recommend going with the first approach, just a loop and 2 variables. It's simple, fast, and nearly optimal. That's all for today. If you found this explanation helpful, don't forget to like, subscribe, or share the video with a friend who's preparing for coding interviews. See you in the next one.